Good morning, students. So we have started chapter 7 indices. In that we have covered till question number 7. So you go through the videos that I have uploaded on the YouTube, and from that you will finish your work. Now we will resume our discussion of this exercise, and let's discuss one question number 8. And in this also we will use the laws of exponent. So it is n minus n into a to the power n upon a to the power minus l, n minus l into a to the power l upon a to the power minus m to the power l minus m, and we have to prove that this product is equals to 1. So first of all, what we will do, see, this is bases are same, so we will subtract their exponents like this. Similarly here also, a to the power n minus l into a to the power l minus m. Okay, so this will be our first step. The idea is we will try to combine all the powers of a. So before combining all the powers of a, first we will combine these two powers. Now what you will get? You will get m plus n to the power m minus n, then n plus l to the power n minus l, l plus m to the power l minus m. So this you will get. Then afterwards what we will do? We will use this law of exponent, a to the power m, that is a to the power mn. We will multiply these two powers. So you will get m plus n into m minus n, then n plus l into n minus l, l plus m into l minus m. Now if you see very carefully, see, it is something like this, a plus b into a minus b. So what was the product? We have studied in the expansions, a square minus b square. So it becomes a to the power m square minus n square minus l square minus m square. Now we have reduced this expression till here. Now see, all the bases are same. So what we will do? We will simply add their powers like this. So these two cancel, this two cancel. You will get a to the power 0, and anything raised to the power 0 is 1. So this is how we will solve the expressions like this. You just try to form the expression in the single form, use the laws of exponent wisely, and then do the required manipulations, and then you will get the answer like this. So a to the power 0 is equals to 1, so we can say that our LHS is equals to RHS. Okay, so next is we have to simplify this expression. So it was like the similar type like we have discussed in question number 8. So again, first we will combine these two. So bases are same, so you can write like this, a minus b to the power a square plus ab plus b square. Similarly, it becomes x to the power b minus c into b square plus into x to the power c minus a, c square plus ac plus a square. Then again we will multiply these two powers. So your result will be looking like this, a minus b into a square plus ab plus b square. b minus c into b square plus bc plus c square, and c minus a into c square plus ac plus a square. Now, if you remember in the expansion, we have studied one expansion of a cube minus b cube. That was a minus b into a square plus ab plus b square. So this expansion we are going to use in this. So it becomes x to the power a cube minus b cube, b cube minus c cube, and x to the power c cube minus a cube. Then again, what we will do, we will simply add the powers. So like this, you just add the powers like we have done in the previous question. So when you see, everything is going to get cancelled and you will get x to the power 0, and anything raised to the power 0 is always equals to 1. So this is how we can solve the expressions by using the laws of exponents and the expansions that we have studied in the previous chapter, expansion. So this is the end of exercise 7a. Next we will discuss another topic in this, that is how to solve the exponential equation in exercise 7b. Okay, so let's discuss the exponential equations. So first of all, what is the meaning of exponential equation? So an exponential equation means, suppose we have something like this, a to the power x equal to a to the power y. So in that case, if these bases are same, okay, condition is the bases should be same. So when the bases are same, in that case their exponent are also equal to each other. For example, if I take 2 to the power x equal to 2 to the power 2. So what is my x? Since these bases are same, so x is always equals to 2. So this will be our basis for solving the exponential equation. We will try to make the bases as same, and then after that we will compare their exponent and we will find the unknown values. So let's solve few questions related to exponential equation. Okay, keep this thing in mind. We have to make bases as same. So let's start the next exercise, that is 7b. So let's see the very first question. So in this, it is given that 2 to the power 2x plus 1 is equals to 8. And with the help of this, we have to find the value of x. Now see, this is 2, this is 8. So both the sides bases should be same. So what we will do? We will convert this 8 into the power of 2. So if you remember 8, we can write it as 2 into 2 into 2. So I have written the 8 as 2 cube. Now we will compare the bases. So when you compare bases, you will get 2x plus 1 is equals to 3. So it becomes a simple linear equation. Now this one will go there and it will be 2. So what is our x? X is 1. Okay, easy. Not very tough. Only thing that you have to keep in mind that the bases should be same on both the sides. Like one more question, see, to make yourself clear, 4x plus 1 equal to 27 the power x plus 1. Now what we will do? First we will make the base as same. This is 27, so we will write 27 as 3 cube. Like this. Again, we will multiply these two powers. So what we will get? We will get 3 to the power 3x plus 3, and here it is 3 to the power 4x plus 1. Once again we are succeeded in converting this right hand side into the same base as on left hand side. So again this powers we will compare, and now it is a simple linear equation that you already knew how to solve, many times you have solved. So you will get x is equals to 2. Understood? So the base to solve any exponential equation is you have to make their bases same on both sides. If they are not same, then try to make them same either by prime factorization or by any manipulation that is needed. So now in this case, see, this is 49, this is 7 and 343. So again we will make the bases same. So this 49 we will write it as 7 square into x plus 4 into 343. How we can write it as 7 into 7 to the power 3. Okay. So either on the left hand side or on the right hand side, if the bases are not same, you should try to make the base as same. And what we know in this is the power of 7 and this is also the power of 7. So I have converted each and every term into the power of 7. Now we will multiply these two powers. So it becomes 2x plus 8 is equals to 7 square into 3x plus 3. Okay, multiplication of the powers. Then now I will add these two powers, 2 plus 3x plus 3. So first we make the bases same, then we use the laws of exponent in this, and then now see both the bases are same. So we can write it as 2x plus 8 is equals to 2 plus 3x plus 3. So you will get 2x minus 3x equal to 5 minus 8. Minus x equals to minus 3. This minus and minus cancel. So we get x equals to 3. So this is the procedure to solve any exponential equation. Now let's see a few other types, like in question number 2. So what we will do first, see this is a sign of root, so we can write it like this. Okay, every root sign, every square root sign we will replace with the power 1 by 2, and this 16 we will write like 2 to the power 4. Now again we will multiply these two exponents, so you will get x plus 3 upon 2 is equals to 2 to the power 4. Then what happens? So their bases are same now, 2 and 2. So we will compare their exponents. Then it is a simple linear equation. You will get x plus 3 equals to 8 and x will be okay. Like this you can solve. Okay, let's discuss another type now. In this, see, again root sign is there. So what we will do, we will replace this root sign like this, and this 125 and 27 is there, so I will write it like this, 5 cube upon 3 cube. In the next step, what we will do, this 5 cube upon 3 cube, we will write like this, 5 upon 3 whole cube. So now it becomes 3 upon 5 to the power x plus 1 by 2 is equals to. Now see the base, it is 3 upon 5 and it is 5 upon 3. Again bases are not same. So what we will do? We will do the reciprocal using this relation that we have studied like this. Okay. So we will make it 3 upon 5 or you can make it 5 upon 3. Whatever you want to make, you can make. So it becomes 3 upon 5 and this power becomes negative like this. Now see, both the bases are same. So we will compare these two. So when you compare, you will get x plus 1 by 2 is equals to minus 3. And from here you will get x plus 1 is equals to minus 6. And that means x is equals to minus 6 minus 1, that is minus 7. Similarly in this, suppose the root sign is there, a number is written there. That means it is the cube root sign. So again how we will remove? 2 upon 3 and this becomes 1 upon 3 to the power x minus 1. Similarly, this we can write it as 3 cube upon 2 cube. So these two powers get multiplied. You will get x minus 1 upon 3 is equals to, this we will combine like this. Again it becomes the same problem. So what we have done in this problem, we have simply taken the reciprocal. Same thing we will do here. So it becomes 2 upon 3 to the power x minus 1 upon 3 equals to 2 upon 3 and this power becomes negative now. So again we will compare their exponents. So what is x? Minus 9 plus 1, that is minus 8. So what are the things that we have done in these type of questions? First we have removed the root sign. Then we have converted this right hand side into the same base as it was there, into its prime factors. Then we take in the reciprocal so that these two bases become exactly same.